Hey everyone, welcome to the third installment of JE Software Creation. So, in the last video we were busy building the Reactive application with coroutines as their backbone. In this video we're going to find out how our application is now working. We're going to add the remaining endpoints and we're going to have a discussion about why are coroutines important and how does this transforms the way we see reactive applications. But for now, let's start out by performing tests to our current running application, what we have built so far, and then let's test it. All right, let's get into it. As we have seen before, we have created three endpoints. So we have created a post mapping, a get mapping, and a put mapping. We are going to create the remaining ones, but for now, let's see how are they playing out and how are we being able to post new articles, how are we able to change them, and how are we able to retrieve all of them. Retrieving we have already seen. Let's do that in a Scratchpad. So we go to the parent module that is our spot-on application, and we will simply just look for HTTP, and then we are able to create an HTTP request file, and then we are able to create a HTTP request file. Let's call it spot-on test requests, like this. And now let's create our first GET request. Our GET request, as we have seen before, is in port 8080. And now we come across one important thing, and that is the standard of how we should create REST applications. Now, welcome to the second gotcha moment in the development of this application. And what it is that we have certainly created an application with three endpoints, but not really with the right standard. So now let's just go to the controller. And here we have post mapping, get mapping, put mapping, but we didn't define an API. How do we define an API? Not here. Let's do it in our application properties file. And here we're going to add something that we can look for by web. That actually is the first hit. The base path, we're going to call it, what is the name of our API? Is spot on. But is it spot on what we want to put here? Maybe the best thing to do is to put API/spot on. Then we can better define that it is an API and the name is spot on. And then we can define different things on it. So my suggestion is always to do it like this, that we have a root path, and we should also add a version. So v1 seems like a good one because this is the first version of this project. So we go here to controller, and then here in the request mapping, we can say that the root is actually what we are trying to manage with this controller. What are we trying to manage with this controller? Articles, right? So we put articles, just as an example. For the rest of the endpoints, because they are so unique and they are just one in every single different operation, it is also understandable to just leave it on the root. So we're going to post map to articles, we're going to get map to articles, and we're going to put map to articles. So let's get back to our Scratchpad, which we have created in the root of the project. So we go here, and then we go to... So if we go to the root of our project, then we have the file that we've started, the spot-on test requests, and then we can change here. So we've named it API spot on, and then we named our endpoint articles. So let's start the application. You see, one of the great things about using Scratchpad is that it literally reminded me now that it's v1. So if I click on that, it knows exactly that I made a mistake. So there you go. So now we've started the application. There's an endpoint available. It will reply in JSON. And let's go. There. Here we go. We have the ID. We have the URL where supposedly the article is. and the name of the article and the intro, do not mess with cat. So we have the first article that we create when we start the application. So now let's create another one, but we will using a post request, which, let's have a look again at the controller. Which we have already available. So let's do that post request using the Scratchpad. So let's go plus, let's do a post. And our post will be, again, port 8080. We will use our spot on application. We will use v1 and it will be against articles. So now we need to send an application JSON, which will contain not an ID, because the ID will be automatically created for us, but it will have a URL, and this URL will be, let's say, localhost 8090, for example. It's not necessary to be a specific one that exists, it's just for the example. Name, let's call it Big House Cats, and let's say in the intro that this will be they are adorable. So this is our post request. Let's do it. Did it work? No. So let's look at the request and see if we can find out what happened. Well, it's a bad request indication, so this is probably related to the payload. Let's check the payload. We have as a payload an ID, a URL, a string, a name, and an intro. Here's the thing. UID is still a val. It is a UID, but it's not being created automatically. So probably we want to do this. Make it unnullable, and in the first instance make that it defaults to null. Let's restart our application. We need to change this construction all over the code. So in this case, ID may be null, and that means that the ID is nullable everywhere. This should take care of the issue. Let's start the application again. There we go, we have the application started, and then we're going to get back to our Scratchpad and send the request again. There we go. Now we've added a new instance, but did we add it with a real ID, or is it now that we have a null request? Well, we can make again a get, and there we have it. We have two different records. One, the Power of Cats, and the other one, Big House Cats. So what do we need to check now? Let's see if we can change one of these articles and their content. So we're going to go to controller again and have just a quick look at our put request. The payload is literally the same. So we can go back to our Scratchpad and say, okay, now I want a put request. Let's add a put request. It doesn't have by default, so we need to make our own completely manually. So can we do it? Sure we can. So put HTTP, then we're going to say localhost API spot on, we're going to say articles, and now we're going to say that this accepts an application JSON, and then we're going to set here our new payload. So the new payload is going to have this ID, which we put it here, and then we're going to say they are adorable and very clean, and let's put it. We've got an unsupported media type, and the reason for that is that if we look at the server, what we are having right now is a problem where he tries to insert our record. So he keeps trying to insert instead of updating. We've said before in the beginning of in the first part of this video, if you remember, that I made a question: would it be necessary to have an ID, or is this not important at all? Well, now I made it on purpose, because now we come to the third gotcha moment of this series, which is that when we are creating a domain and we want to put data in the database, we may skip a couple of things, but one of the things is still extremely important to have, and that's the ID. And this is very logic, because IntelliJ and the compiler and the runtime, they cannot determine which one of these is the ID. So it will try to blindly put the record on the database. And if we are trying to make an update, it needs to find out exactly which record we want to update. So having this ID will hopefully solve our problem, but we have to do the whole thing again. And that's a reason why why our Scratchpad is so important, because now we keep a history of all our requests. So now we have the post request. So we put now our Big House Cats article, and now we're going to update the Big House Cats article with the ID that we got back. So this ID. But let's just check it if that's okay. It is. That's what we have now in the database. So let's make our put request and update this. There we go. Now we get an okay, and in principle we were able to update the article. But let's double check. So getting the requests again, we see that they are adorable and very clean. We still have only 2 articles, and it has been updated. All right, now we have our post request, the get request, the put request, and we want to make the patch request. Now, for the patch request, what I have seen in my experience as a software engineer is that in many cases people implement a patch request like a put request. And we get an ID in the URL, which is also part of the definition of a patch request. But we also get in the payload everything related to an entity. We don't want that. We essentially just want to say, hey, I want to update my entity in the database, I want to update this property, and I want to run with this operation. So before we start with the patch, I think it's very important that we revise the RFCs that really talk about this. So there is a very interesting blog about someone by the name of Cassio Molin. I hope I pronounced that correctly. And there he really mentions how a patch request should be done, taking his references from the RFC definitions. So let's look into them before we start with patch. So if we look at the, for example, if we look at the patch method for HTTP, not this one. If we look at the Java object notation, we see that there's a lot of definitions here about how should we create a Java object. If we look at the patch method for HTTP, we have a lot of text here that we could read about, but essentially what they mention is that our requests should comprise something like this. So we have an application example, we have a patch, and essentially we want to change a bit of the resource. We don't want to change the whole thing, we just want a little bit changed. And to do that, if we go further down the line, it is mentioned here that we should create our request with the ID in the URL. If we scroll the text a little bit further down, we see that there is an introduction, and then they talk about the patch method. Let's go there. So when we read this text, we see the patch method requests that a set of changes described in the request entity be applied to the resource identified by the request URI. So the resource has to be identified in the request URI. In this case, we know that we can use either a query parameter or a path parameter. We will go here with a path parameter, and when we look at the other RFC, so this is RFC 6902, not that the number is very important, but it's where it is defined. If we scroll all the way down, we can see examples of operations. And if we go to operations, we see all of these descriptions. But what's important to highlight here is that the payload is a standard and must be a standard. And the standard is that we have an operation, we have a path, and we have a value. The order is not significant, so that's why they put all the different options as an example. But what's important is that we are specifying that in our case, we don't want to add, we want to replace. Our path is going to be the URL, just /URL, and the value is going to be the new URL. Now, there are many ways to implement this kind of protocol. We're going to do it manually because it's easier, and also because it makes it more obvious how a patch request should be implemented. So if we see the documentation provided by this blogger, Cassio Molin, then he does explain all the different libraries that we can use. It is quite a complete blog, but again, we don't have to do all of this for what we want. We just want one operation, and we can still hold up to the standards that the RFCs restrict us to do. So let's simply just implement that. So let's go back to
IntelliJ.
our IntelliJ.
So what we've done so far is to figure out the standard for our patch request. So if we go here to controller, we have already a patch mapping implemented. So I've done this while I was giving that presentation. And essentially we have nothing in it, and we just have a patch spot on with a JSON node in it. The idea of using a JSON node here is so that we can quickly implement this. There are different libraries. If you read the blog I've just shown, you will find that he's using a specific library to interpret the requests. We don't have to do that per se. So let's not do that, because otherwise we have to really create a different, the whole backbone to support just our simple patch request. What we could do here is, on the basis of the RFC, create our own interpretation of the request. So a JSON node will be just a node with all different kinds of data in it. It will also have metadata, and using that metadata we can get our data, and then from that point onwards we can build our patch request and even validate. So let's do that. So let's go to the RFC that describes how the JSON object should be built in order to issue a patch request. This is where it's being described. So as we have seen before, we've got an op, a path, and a value. The order is not important. Well, if it's not important, then it's really easier. So what we need to check in our controller is, okay, which operation do I have? And should I do any other operation? No, right? So we should just do one operation. So the method is empty. So take a few seconds to think, what are we missing in this patch mapping, according to what we've just said about what we have seen in the RFCs. I hope you figured it out what it is. It's very simple. We are actually missing the ID. So the ID should be just a UID. In this case, we're going to say that, okay, we're going to call it just an ID. We're going to use it as a path variable in our request. So, path variable, and this is going to be ID. All right? Okay, so now we've got the ID, we've got the patch. Now we need to validate if our request matches what we need. So we're just going to say, okay, if JSON node.get op is replace. So let's take this moment to segue into how we make code and how we structure our code in our environment. So here we already started developing some sort of business logic, which does not make sense to put it in the controller, as you know. So let's pick it up, take it from here, and we'll create a spot on service patch update with input parameters ID, and we'll be using the JSON node to do the parsing operations that we need for this function. So let's add it, let's create a member function. Now our member function, of course, we wanted to return a spot on DTO, and here we want to copy paste what we've started in the controller. Now, after doing this, one good thing to do is really to check if in this method, because we are only patching the URL, and that's a good thought actually, let's rename patch update to patch update URL. There we have it. So now let's check that the path does matches what we want. So get URL, not URL, sorry, path should be URL. But if it's not URL, then what we should do, we should return some sort of error, right? But let's not do that. We will throw a runtime exception with the text, anything we would like to use in this case, but probably the most important thing here is to tell the client that this service only updates URLs, that this endpoint only updates URLs. So for that, we can say this endpoint only updates URL. Please update your request. There we go. If the operation is replace, we check if the path is URL. If not, if it's not a replace operation, we're going to say, simply put another, we'll throw another exception. And here we're going to say, hey, this endpoint only performs updates to the URL parameter. That's it. So now we've passed operation replace, we've passed path URL, and now it's time to check the value, or better said, we're not going to check any value. We're going to update it immediately. So how do we do this? We apply. So what are we going to do here? We're going to say apply patch, and we're going to apply it blindly to our entity. So to get our entity, we need to get our spot on repository, and then we find by ID. The ID is the ID that we get as a parameter, or we find by ID. Of course, this is a spot on, not a DTO, but just a spot on. So this is the spot on we need, and here it is complaining about, of course, as you know, this function needs to be a suspension function. And having done that, now we can apply the patch. If you notice, line 27 and line 28 are still underlined as red. The reason being for that is when we do JSON object get, we actually get another JSON node. What we need to do is get text value for it, and then it will accept that as logically it should. So now we have the spot on object that we need. We need to apply the patch to it.
So one of the things we can do, we just, since this is Kotlin, we might as well just apply an extension function for it. So let's do it. So spot on, apply patch. And what are we going to do with this apply patch? So we're going to apply patch with the JSON object. So now let's just create an extension function, spot on extension function. Now we're applying the patch. So now, as we said before, we did the checks, and now we apply the update. So we did the checks, and now we apply the update. So now we have spot on apply patch to the JSON to our object. So what do we know? We know that when we get here, we have the URL. Everything is ready for us. So we're going to go here, and we're going to say, all right, in my JSON object, in value, I can find my URL, and then what I can do is return a copy of my spot on object with the URL as the URL we just found in the JSON. We don't need to use, notice that IntelliJ created automatically a spot on nullable object. We know for sure we don't want it to be nullable. At the moment we apply a patch, we are sure that it is not null. Here we do have to specify that precisely that. So we make a require not null, and there we go. So now we have almost what we need, only that it's not yet complete. We haven't saved our object yet. So what we need to do is to again use our spot on repository. We need to save this one more time, and of course we need to return it. So we need to say return apply patch to data. So let's now go back to our Scratchpad and make this patch request. So now we know that for our patch request we need to add a UUID. We don't know which UUID is that. So let's kickstart our application, press play button, and wait a bit so that our application starts. So now what we want to do is we want to test our patch request. So our patch request is very similar with a put request, although also quite different as you've seen. So let's say, okay, we have a patch request. This is the endpoint, but now we know that our payload is very different than this. So what do we do with our payload? Well, we already have it here. So we already know that the ID should go to the path of our patch request, and we also know that the URL is the value that we want to change. So instead of localhost, let's call it localhost, just as an example. And we do not want to change the name, we don't want to change the intro, of course we just want to change the URL. If that's the case, let's now give it the operation. So the operation is replace, as we have seen. Further, what else do we need? We need the value. So the value is not URL, the value is value, and the path is URL. Like this. However, we do not have this record on the database yet. So this is just to give an example of the format that we want to use to make our put request. So to have an ID, we can first check our records, right? So we want to first check the records that are on the database. So we do a GET request and we see, okay, power of cat, do not mess with cat. That's the record we add in the beginning of during the startup of the application. So now getting back to our patch request, okay, we have the wrong ID, of course, so we're going to add this ID. I'm going to put it here. And now, here's the fireproof test. We have the ID, we have an op
for operation replace. We have the path, so that's the parameter we want to change, that's the URL. And then we're going to give it a new value. So we have ID, replace, path, value. Let's do it. Let's run patch. It says an OK. And look, we get as a result a DTO with an ID, the new URL, the name power of cats, and then do not mess with cat. And let's check with the ID. That makes sense. Now let's check if this really worked with another GET request. Look at that. We were able to patch just the URL. So having done all of this, what are we missing in our application that we said that we would make in the requirements? The head request. Let's go to our controller and let's edit. Now, Spring Boot does not offer an HTTP mapping for head requests out of the box. So we do not have a head mapping. So I can show it to you. Head mapping. IntelliJ cannot find it. We can trick this a bit. So we can make a request mapping. And we can say that the method is a request method head. And then here we can create our suspend function. It's going to be a head spot on. In order for us to see a bit of the dynamics of the head request, let's make it a bit more fun. And so let's go here and let's say value is an ID. So we're going to have a path variable. It's going to have the same name, literally what we have in the request above for the patch mapping. So for our head request, we now probably just want to return spot on service dot get, not a get all, but we want to get by ID. So we're going to say get spot on by ID, and this is our ID. And now we're going to create the member function, and here we're going to say that we're going to get everything from spot on repository, find by ID, and this is going to be this ID. Now, one of the important things about this is that, of course, it needs to be suspend, and we are, in this case, returning a nullable. And the reason for that is that we do want our application to be very simple and keep it simple for now. So there we have it. We do see that the ID cannot be resolved. Well, if you noticed, I forgot to add this curly bracket. So let's check this one also. So let's go to spot on request HTTP, our scratchpad, and now let's create a head request. So we're going to, well, let's make it nice and pretty, so like this, and we're going to say head, and we're going to say, okay, we're going to go to this same path that we use for all other requests. Now, we still have our service running. We're going to have to stop it, so we're going to lose our record. But that's not an issue. We're going to do the same get and update as before. So what do we know about this? Well, are we accepting JSONs? Are we doing anything special there? No. So we might as well just leave it this way with an actual complete path for a UID. This UID doesn't exist. Wait a bit. Let's start the application, and if it goes well, we can now get all of our requests. We can now get all of our articles. We only have one, of course. We can do this, and we can add this one here. And if this all goes well,
we're going to make the add request, and the head request, the only thing that is going to return back to us is the size of our entity. Let's do that. There we go. The size of our entity is 133 characters. And we could also check if this is true or not. So let's make our GET request again. Let's copy this whole thing. This is our complete request, and let's use, for example, this online character counter. Calculate. So now we have 173 characters, right? So, but it should be 133. So let's go here. Let's compact this. Really compact it. $138. Go there, here, go a bit like this. 136. 135. And we probably have some spaces somewhere. Oh, of course. This. 133. Because we are returning this whole entity. So it is 133 characters long. So, and that's everything that we get from a response of our head request. It doesn't have a body. We should not use a body in the head request. And as I said before, it's specific just for metadata. So look at this. We have all of our requests. We have a post, we have the get, we have a put, we have a patch, and we have a head request in our REST application service. So this completes our goal for this tutorial? It does. This was it. This is our Coroutines-based reactive web application. So let's now reflect a bit on everything that we did to achieve this. First, we created in part one of this tutorial, we were mostly busy designing what we wanted to achieve in our application. In the second bit was a bit more practical, and we did the basic, more common endpoints, different types of endpoints that are used. And in this part, in the third part, we've completed the whole cycles of our application. But let's have a look at now the way the code looks like. So we have here our REST controller. If you remember from the typical MVC model, so the blocking model of, or let's put it this way, the way we used to implement Spring MVC applications, we didn't used to have suspend. We didn't use suspend anywhere. So suspend is just an indication that this will be a coroutine. Then we have this, and get all spot on articles, and the spot on articles will be delivered as a list. And if they are delivered as a list, they are actually delivered as a flow. Now this is something important to understand. Flows, just as I mentioned, I think on the first part or the second part, well, the episodes before, it relies heavily on coroutines implementation. So this will make a better use of our threads. All of what we see here is very much the same thing or similar to what we have, if you know this, in reactive applications with Webflux. We have still the usage of monos and flux. So flux is something that's mostly used to provide a list of different objects, and a mono would be just for a specific entity. We can make a parallel there, thinking that suspend is something, it's the way you do it with coroutines for monos, and not using suspend at all, but using flow is the way to do it in the way Flux did it. Now they have good interoperability with each other, but the point is, when you look at this code, the differences between this and the blocking model are hard to spot on, because if you look at it, the only difference is that the suspend keyword is there. But apart from that, the code is just as readable as in a blocking implementation. And if we look at something more complicated, like the way we did the patch updater, well, our patch update changes the URL, okay, but look at the way the code is implemented. I'm not sure if an if under an if would be the best option here, probably not. Cyclomatic complexity and that kind of thing. But what we can see here, and that's what most people are saying, is that we can go back to implementing imperatively. So apart from the suspend keyword, also for the repos, we don't need to worry about monos and fluxes. Now, there can be a great discussion here about, is this a better thing? Is this a worse thing? Is this something that will make us think out of the box? Or is this something that will make us do things easy just because they're easier? Now, there's a very philosophical discussion going on, but what's important here to see is how actually coroutines can make life much easier when we are implementing a REST application. Aside from all of the discussions that we can have about comparing things, comparing how easy it is to make blocking and how a bit more complicated it can be to make a reactive application, what are the goals or anything like that, we can say that the blocking model is definitely the easiest one. Reactive, we can say that with coroutines, then that would be the next easier thing. And we have on the most complicated side of the scale using monos and fluxes without specific use of coroutines. So I hope that you've enjoyed my example. I really did my best to make this first series of tutorials for you. I hope you found that this is in any ways something that is spot on for what you need in your work life or even personally, your hobbies, I don't know. So let's recap a few things that we have learned so far here. We've learned about coroutines. We've learned about how to make a patch request. We've learned how to make all the other different requests which fall under the RFC standards. And we've seen how can we access a database and get the data traffic between the front end and the back end and through the different layers. This onion architecture, how can we get the data flowing from one side to the other and back? What we have not seen in this video is why are coroutines important. That will be a subject for a next video, for one of the next videos that I will do. For now, again, I hope you've enjoyed this video. I hope you've enjoyed all the other. I hope you've enjoyed the first two videos of this same tutorial. There will be a follow-up to this project. So I will talk in the coming video about why shouldn't we use H2 in the database and where H2 actually plays a good role and where maybe it's not needed anymore. If you enjoyed this video and any of the two previous videos, please leave a thumbs up. Please subscribe to my channel to not miss out on any further videos that I will do. And until then, keep it graceful and stay sharp.